Hello, everyone. Welcome to OCC Math Seminar session. Today's session is trigonometry. So we're going to talk about trigonometry of right triangles. The objectives is circle of radius is not 1. And the second objective, we're going to go through some application of trigonometry of right triangles. When we first learn about circle in trigonometry, we learned about unit circle. Right? So uni mean 1. So that means that circle has a radius of 1. Today, we're going to talk about a circle with the radius r. R doesn't have to be 1. Right? It could be any positive real number. So this circle right here, I have the radius r. The angle is called theta. And then the two legs, y and x. Y is the side value, sometimes people call it the height. The x is the cosine values, sometimes we call it the width, right? So you might have heard the expression SOHCAHTOA, right? So let me write it down here. SOHCAHTOA. So SOHCA is for the sine. Oops. So that's the sine equal opposite over hypotenuse. And the car, let me highlight it in blue. It's a lot of keep up with color here. The car is the cosine. So cosine or cos is equal to adjacent. A is stand for adjacent. ADJ over hypotenuse. And then last, TOA, let me highlight in green. Move everything to the left a little bit so I have more room. Is central the tangent, right? So tangent equal O opposite over A is adjacent. Okay, so you might have heard of that expression, right? So here's, in order to find a sine theta, it is equal to y, the leg y over the radius r, or opposite over hypotenuse. Now the cosine theta is just the reciprocal of the sine theta, right? So all you do is just flip the fraction. So instead of y over r, it would be r over y. And it's similarly for cosine, right? It's adjacent over hypotenuse, so x over r. And then tangent is opposite over adjacent, or y over x. Right? And secant is the reciprocal of cosine theta. And then cotangent theta is the reciprocal of tangent theta. Okay. All right, so those are 3 rules, basic rule of a circle of radius r. Okay, so let's jump into some example. I have cosine theta equal -4/7, and it say that theta is in quadrant 3. So let's check if our problem makes sense. So here's for quadrant. We know that quadrant 3 has -x and -y, right? Now cosine theta is adjacent over hypotenuse. Hypotenuse is the radius, so the radius cannot be negative. So the 7 cannot be negative. However, the 4 can be negative, right? That would be -x over r, which makes sense, right? Because when you draw a right triangle in the 3rd quadrant, it looks like this. Let me move the ruler. Oh, let me move the ruler up a little bit. Okay. All right. So here is our angle oops, angle theta. Right. By the way, when you draw a right triangles, one of the legs is, it has to be the x-axis, right? Because that's your x, right? And the vertical leg is parallel to the y-axis because that's your side, right? Some people draw like this. Don't write this down. And they have this and that's wrong, right? That's not the right way to draw it. So okay, so that's theta, angle theta, and then we know that cosine theta is, we know from the rule above here, cosine theta is x over r. Right. So x will be this one, right, which is -4. And then r, the radius is 7. Now, they want you to find the remaining trigonometric functions. So sine theta is, we know is y over r, right? So y over r. Now, we don't have y, so we have to find y. We're going to use Pythagorean theorem to find y. So I'm going to put a question mark here. So I know that question mark square plus -4 square equal to 7 square. A squared plus b squared equals c squared. Question mark square, or maybe I'll replace question mark with y, maybe. Let's just do y squared. So y squared is what we're looking for. -4 squared is 16 equal 49. Subtract 16 both sides. Y squared equal 33. And then we take a square root. Now, mathematically, when we take a square root, we should have plus and minus. So y equal either plus positive root 33 or negative root 33. Which one do we choose? Well, it's a third quadrant, so y value is also negative. Okay? So we're gonna choose minus root 33. All right, now we have y. All we do is just fill in those trigonometric functions. So sine is y over r. Y is negative root 33. Let me rewrite my root and my negative sine. Over r, which is 7. And then the cosecant theta is just the flip of sine, right? So just flip it over. So -7 over root 33. If it bothers you, you can rationalize this. Multiply both top and bottom by root 33. I don't think it's a big deal. This is not an algebra class, but I'm just going to show you the first one if it really bothers you. So this is equal to -7 root 33. Root 33 times root 33 is root 33 squared, or 33. If it really bothers you. Right. Cosine theta is well, we have it right there, -4/7. And then secant theta is just a flip of cosine theta, so -7/4. And then tangent theta is opposite over adjacent, so y over x. Negatives, remember y is have negative value as well, so negative root 33 over -4. Oh, the negative cancel, so it's be positive. And the cotangent is to flip the tangent, so 4 over root 33. Again, if it bother you, multiply both top and bottom by root 33. We got 4 root 33 over 33. All right, number 2. Given f of theta is equal cosine theta equal 0.3. So they tell you that the width of the function is 0.3, where theta is in quadrant 1. It's important that you know what quadrant you're in, right? Otherwise, you don't know where to start. So let's draw this. It's the first quadrant. 0.3. Okay, so maybe I'll, oops. 0.3. We'll do it like this. Okay, all right. All right, so here's our data. Here's our data. And the function, the width is 0.3. So that means this bit right here. Yeah. Go down here. That means this bit right here is have a length of 0.3. That one I highlight in blue, so you can see. 0.3. Right. Now they want you to find f of theta plus pi. Well, pi is equivalent to 180 degree, right? So from that terminal right here, from this point right here, you're gonna go another 180 degree. So what that mean? I mean you go like this. So that's pi or 180. Rewrite pi like that. So that means if I extend that little red line, it looks like this. What that means by going theta, so theta, and then add another pi angles. Okay, so what do you think? Well, symmetry. My picture is not very good to symmetry, but let's see. See if I'm gonna try my best. Like that. Like that. All right. So by symmetry, this one is also theta. This angle right here is also theta, right? And this length right here, the length is also 0.3. However, because it now is the left side of the origin now is going to carry the negative value, so it'll be negative 0.3, right? So when I draw my cosine theta plus, so we know the f of theta is 0.3, but we want f of theta plus pi. So that means we want plug into the function. Now substitute theta with theta plus pi, right? That means from theta you go another 180 degrees. You go over this side on the third quadrant. But if you project the length, it is the same length. It just carry a different sign, right? Because it's on the left of 0. So that means is equal to negative 0.3. So this bit right here is negative 0.3 mathematically. Right?